Interactions between folding, erosion, and sedimentation. In active mountain belts, folds grow while rivers and hill slopes erode them, and the eroded sediment is deposited in nearby basins. This two-way interaction controls whether an anticline becomes a rugged ridge or gets buried by its own sediment, and whether a syncline stores sediment as a basin. First, let's build a simple cross-section showing an anticline and an adjacent syncline. Then we will place uplift and erosion on top of it and see two contrasting outcomes: rugged growth when uplift wins and burial when sedimentation keeps up. Case 1. Uplift is faster than erosion. The anticline builds relief, slopes steepen, and rivers insize gorges. Case 2. Erosion and sedimentation keep pace with uplift. The crest is planed off and sediment buries the limbs into a broad plain. The stratigraphic record captures this interplay through what we call growth strata. Layers deposited while the fold is growing thicken toward the basin, onlap the limb, and develop angular unconformities during pulses of uplift. Now, why does this matter mechanically? Uplift builds topography. Erosion moves that mass into basins. Sedimentation loads the crust, which can influence where and how the next fold grows. It's a feedback loop. Erosion patterns reveal fold dynamics. Long linear folds often show trellis drainage cutting across the limbs, while domes can develop radial drainage. Wet climates speed erosion. Arid climates preserve relief. Orographic rain can focus erosion on the windward limb, producing asymmetric folds. Sediment can pond in piggyback basins that ride on top of moving thrust sheets. As a fold propagates, the depot center migrates, leaving a record of basin shallowing and tilting on the back limb. How do we gauge the balance between uplift and erosion in the landscape? A simple clue is relief and slope. Active folds tend to have higher relief and steeper slopes than older, dormant folds. Over long times, some landscapes approach dynamic equilibrium. Uplift and erosion rates match on average, so relief and slope distributions remain statistically steady, even as rock continues to rise and sediment continues to be shed. Let's summarize. 1. Erosion can limit topographic growth of folds and even influence their structural evolution. 2. The sediments shed from folds accumulate in adjacent basins and record the growth through growth strata. 3. Sediment loading and unloading feedback on where new folds and thrusts develop. For climate modulates erosion, which shapes drainage and fold asymmetry. The landscape we see is the ongoing outcome of uplift and surface processes working together. By reading geomorphic forms and stratigraphic records together, we decode the tempo and mode of fold growth in an ever-changing surface environment.